Right, guys. Good evening.
Hi, Kranti.
Hi. Hi, Sid.
Kranti, you didn't share yesterday's class video yet, did you?
So I'll be sharing it today. So you'll
Oh,
be
okay, yeah.
getting alternative days. So 2 days classes would be shared at a go.
Oh, okay, yeah.
Okay. But how are you finding it? Is it okay? I mean, are you able to understand the concepts, Sid?
Yeah, I'm able to understand, Kranti. It's just that I've been practicing, but what happens is that, I told you, like, I could not download the latest version of the Tableau.
Mm-hmm.
I've been like downloading like 10.3, like the older ones.
Okay.
So it's like some of the servers are not working on the older ones. So it's like, but using the older ones, I'm able to like look at your videos and practice also.
Okay. Great.
Yeah.
Yeah. Right. So in yesterday's class, we have discussed about different types of charts and visualizations that are available in Tableau. So using show me function, there are total of 24 chart types where you can uh, input the different measures and date fields. So based on the fields in the view, so you'll be able to see the highlighted charts. So basically we can divide these charts into univariate, bivariate and multivariate based on the number of measures used in the view. So we have seen that there are three types of bar charts: horizontal, stacked and side by side bar graphs. Also in line we have discrete lines, continuous lines and dual lines. So we have seen that in area chart also we have discrete and continuous. So area chart is an alternative to a line chart. So we also see in maps, different types of maps like symbol map and field map. Okay, so we also see in tree maps. So to show a large information at a small at a little space. So basically the higher the number would be on the left and the smaller number would be on the right. So the values would be from left to right. Okay, so that means the size of the tree map will decrease from left to right. We also have text charts. There are two types of text charts.
So, Kranti, I have a question real quick. I mean, I forgot to ask yesterday. So when you have that data and everything, like how would you know which thing to use? Like would that tell you, or we have to visualize it by looking at what we have and then figure out like which graph we will be right for that one?
Okay, so I'll be sharing a document with you, so which
Okay.
explains you which type of chart is better for which data type. Okay,
Okay.
so today, once I get the recording of today's class,
Mm-hmm.
I'll also send that document as an attachment. So
Okay.
in
Sounds
that
good.
document, so I'll also discuss that at a later point of time. So in another class, so that clearly explains you to choose different chart types based on the data that you are using in the view.
Okay.
Okay, even here also you'll be able to see some suggestions in Tableau based on the fields that are using in the view. Okay,
Okay.
right. So once you hover over the chart type, you'll be able to see at the bottom. So what are the field types that you have to use? Okay, so once you have those, so you'll be able to see the highlighted versions of the charts here. So for example, in a map, you have to have at least one geographical dimension or zero or more dimensions or measures. So we have to make sure that these fields are there, dimensions and measures are there in the view, columns, rows and marks cuts. So once you have these particular fields in the view, you will be able to see the different chart types. So this is one option. So I'll also share you another sheet where you will be able to take a decision of what chart to use based on the data. Okay, right. So we have text data here. um, We also have mm, bubble chart and also pie chart, and we've discussed about scatter plots and quadrants. It is also called as a quadrant chart. So we have heat map here. So heat map uh, is in the form of a table or a grid. So so it can be used in univariate or a bivariate analysis as well. Okay, so we have box and whisker plot. So this is mainly used for distribution of data. So if you want to show distribution of data, you'll be using this box and whisker plot. So we have histograms and also Gantt charts. So these are the different chart types that we have in Tableau. Okay, so um, after finishing this part, we have started the section called calculations. So in calculated fields, we have seen how in a date in the editor formula editor, what are the different options that we have, and what are the um, what are the features and the comments, field names, the parameter, colors. So all these things have been discussed yesterday. So the within a calculated field, we have discussed that we can use functions, fields, parameters, and also comments. Right. So we have performed a task to understand this calculated fields better, and we have started to discuss uh, all the functions one by one. So uh, we have started with numbers. So yesterday we have completed ABS. So ABS function actually returns the absolute value. If you take a negative value or a positive value, it will always return a positive value. So if you take ABS of -7, the result would be 7. So this is a uh, usage of ABS function. So there are different types of functions: number functions, string functions, state functions, type conversions functions, logical functions, aggregate functions, user functions, and table calculation functions. So we'll see all these one by one. Right. So within this number functions, so we have trigonometry functions. Okay, we have trigonometry functions. So um, what are trigonometry functions? Trigonometry functions are nothing but uh, the functions which deal with three sides. Okay, so the functions which deals with three sides are known as trigonometric functions. So in Tableau, we have four different trigonometric functions: sine, cos, tan, and cot. So in Tableau um, so we have tan, sine, cos, and cot. So we have cos, cot, tan, and sine. So we can find out the trigonometric functions in using calculated fields in Tableau. So what is the syntax of this? So we'll first see sine. Yeah. So the syntax of the trigonometric functions is mm, trigonometric function, um, in brackets, radians. So that will give you the value. So first we'll first look into what a uh, trigonometric function is. So here, so we might have studied this in high school. So the if you the sine is nothing but the so if there are three sides, and the the slanting side is called hypotenuse. So for theta, see, this is the opposite side and this is the adjacent side. So for sine theta, it's opposite side by hypotenuse. For cos theta, it's adjacent side by hypotenuse. So this is a calculation for sine theta and cos theta. So tan is sine by cos, which is opposite side by adjacent side. So cot is nothing but the inverse of tan, so which is adjacent side by opposite side. So we'll be calculating these trigonometric functions in Tableau. So in Tableau, we don't have directly cannot understand Tableau directly cannot understand degrees. So we have to take the degrees in terms of radians in Tableau. Okay, so the syntax of trigonometric functions in Tableau is trigonometric functions of radians equal to value. So this is the syntax of trigonometric functions in Tableau. So by default, Tableau Tableau cannot understand degrees. So we have to take the degrees in terms of radians here. So what is a radian? So radian is nothing but 180 degrees. Okay. Here 180 degrees. Okay. So or you can also say it's 3.14. 3.14 as a numeral, or you can also say 22 by 7. Okay, so radians is nothing but 180 degrees or 3.14 or 22 by 7. So uh, if you want, for example, uh, cos theta or sorry, cos 30, we have to write cos of pi by 60. So pi means, what is pi here? So pi is 3.1415159. So here pi value is 3.14159. Okay, so this is the pi value. Okay, so if you want cos, for example, cos 30, we have to use uh, in terms of radians. So how do you convert 30 degrees in terms of radians? You write pi means uh, 3.14 or 180 degrees divided by 6. So 180, this is nothing but 180 divided by 6. So this gives us 30 degrees. Okay, so we write this in formula. Cos 30 is cos of pi by 6. So which gives 180, which is nothing but 180 by 6, which is 30 degrees. Okay, so we convert uh, degrees into radians because Tableau doesn't recognize degrees here. So in the formula we will write uh, sine cos of pi by 6. So we'll see how we can do that. Okay, so the syntax is this. Syntax is trigonometric function of radians equal to value. So pi is 3.14159. So so now we'll perform a task to find out um, sine 30 plus cos 30. So we'll name sine 30 and cos 30, and in the formula we will write sine of, so we want 30 degrees, right? Sine 30 degrees. So to calculate 30 degrees, we will write pi, because we're converting these into radians. So pi is nothing but 180 degrees by 6, which is 30. Okay, pi plus cos of pi of pi by 6. So this is sine 30 by cos 30. So the calculation is valid like this. Okay. So click on OK now. So now a calculated field will be created in the under measures like this, sine 30 plus cos 30. We should drag sine 30 and cos 30 into rows now. And convert it into dimension. Okay. So now we have 1.36603. So this is the value of sine 30 plus cos 30. Okay. So this is how you can calculate trigonometric functions using Tableau. Similarly, we can also create different values. So if you want sine 0, you can directly write sine 0. If you want to display sine 0, cos 0 and tan 0, we can display them like this. So drag sine 0 into the view and then convert it into dimension. So we have 0. Similarly, sine 0 is 0 and cos 0 is 1. So if you write cos 0, you will get the output as cos 0 is 1. So we'll write cos 0. So we'll drag this into the view and convert this into dimension. So cos 0 is 1. So this is how you can create different uh, different angles, degrees. Sorry. Also, we can calculate any degrees sine cos sine 15, cos 15, or tan 50, tan 75, or cot 75. So all we need to do is, so we need to divide. So if you want to have for example, if you want to have sine 15, we have to divide this by pi of pi by 12. So this is 180 by 12, which gives 15. Okay. So this is cos 15. We'll convert this into dimension and you will get the value of 0.258819. Okay. So similarly, if you want uh, say tan 75, so we will take tan 75 now. So 180, how much should we divide to get 75 with by 180? So you should divide that by 2.4. So 180 divided by 2.4 gives you 75. Okay. So you drop tan into the view and then convert that into dimension. So this will give you 3.73205, which is tan 75 value. Okay. So similarly, you can create any degree and you can perform the trigonometric functions in Tableau. Okay. So these are the different trigonometric functions that you can use. So what are they? Sine, cos, cot, and tan. Then, so we also have inverse trigonometry functions. Okay, we also have inverse trigonometry functions or cyclometric functions. Okay, so we'll go to numbers here. So what are inverse trigonometric functions? So we have a sine, so which returns the arc sine of the number. So we also have a cos, a tan, and a tan, a cos. So these are all the inverse trigonometric functions. So these are also called as cyclometric functions. Okay, so these are called inverse trigonometric functions or cyclometric functions. So these functions will take the input. Okay, so take the input as number and will give output as radians. So if you take a sine of 1, it is taking the input uh, input as value. Okay, so the syntax is uh, inverse trigonometry function, which is a sine here of value. Value is 1 here. So it returns radians. It returns radians. Okay, so the syntax is inverse trigonometric function of value equal to radians. So um, a sine of 1. So if you take a sine of 1, this is calculation 1, convert it to dimension. So this will give you the value in radians 1.5708. Okay, right. So we also have degrees here. We are looking at number functions where we have degrees. Okay, so degree converts radians to degrees. So we can convert if you have radians, we can convert that into degrees. So the syntax is degrees of radians equal to degrees. So degrees of radians equal to degrees. Okay, so for example, if you write degrees of pi by 4, so this is which is 180 by 180 by 4, which gives you 45 degrees. Okay, you can write degrees by 4. Okay, so this will give you the result. You'll have to drag into the rows and then convert that into dimension. This will give you 45 degrees. So this is converting radians into degrees. Similarly, we have radians. We have radians here. So it converts degrees to radians. So the it converts degrees to it is similar to degrees function. So it is vice versa. So it converts degrees to radians. Okay. So we also have power. So power syntax is power of number, comma, the power. Okay. So you have to this returns the number raised to the given number. Okay. So the syntax is power in brackets number, which is 5 here, and comma and power. So it gives 5 power 2. Okay. So we also have square here. Square will square the input number. So the syntax is square of number. Okay, square of 5 is 25. Square of 10 would give you 100. Similarly, we have square root. So sqrt gives the square root of the input number. So the syntax is sqrt of number. So sqrt of 25 is 5. Similarly, sqrt of 5 would give you somewhere around 2.24. Okay. 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 So square root of 2 is 1.41421. Okay. Right. So similarly, we have other functions in numbers. So the mostly used function is div. So div is division function, which takes the input as two integers. Okay, it takes the input as two integers. It divides the first integer with the second integer and returns the output as again as an integer. Okay, so div of integer 1 and integer 2. Integer 1 is 11 and integer 2 is 2. So it divides um, 11 with 2 and gives you again an integer. Okay, so it will not show you any decimal points. It will return only an integer. So you so um, okay, for example, it should be in decimals, 11 divided by 2. However, it will show only 5 because the resultant set of div is only integer. Okay, so even if you take 5 comma 2, so the result is 2.5, but div function shows only integer and not decimals. Okay, right. So we have sine function here. We have sine function. So sine function takes the input as number, and it gives you uh, +1 if the number is positive, and then if the number is negative it gives -1. So if the number is positive it gives +1, if the number is negative it gives -1, if the number is 0 it gives 0. Okay, so um, for example, if you take, so in calculation 3 we'll edit this. So sine of -5, what will this return? It will return -1. So similarly, if you change this to positive value, it will return +1. It will return +1. Okay, so if it is 0 it will return 0 here. Okay, right. So this is the usage of sine function here. So we'll actually perform a task to understand this usage. So we'll first use customer name into rows. What we'll do is we'll display customer wise profit signs. So profit could be negative or positive. So for that we'll display profit signs. So first we'll take customer name into rows and then profit into columns. So we'll create a calculated field. We'll name it as profit sign. And the formula that we use is sine of sum of profit. Okay. So here we have created a calculated field, and now we will drag the sign of profit into columns. Okay. Now we have two marks cards here. So we have in the calculation formula, if we take any aggregation, Tableau will indicate that field as AGG. So you are able to see AGG here. So we are getting the AGG because the calculated field called profit sign, we have taken aggregation of sum. So if a calculation is already having a sum aggregation, it will show it as aggregated field by this visual cue AGG. Okay. In the calculation formula, if we take any aggregation, so we have taken in the calculation formula, we have taken aggregation of sum. So Tableau will by default indicate that the field is in an aggregate mode. So indicated by AGG. So that means the field is already aggregated. You cannot aggregate further. Okay. So this is the visual cue. So we can drag this profit sign into color also now, and you can show this profit sign in label for only profit, aggregated profit sign, and for sum of profit we'll show label as profit values. Okay, so and change the color as well. So here we'll use negative profit as red and positive one as green. Okay, so here we'll able to see, okay, profits like this. So you can even sort the items so that if in the first place you will be able to see only customers who are profitable, and then customers who are in negative profit also, who are making losses. Negative profit means losses. So these are the customers who are giving us losses, and these are the customers who are profitable in nature. Okay, so using this sine function we can do this analysis. Okay, we can do this analysis, right? So this is one of the important functions that is useful while doing profit and loss analysis. So we have one more function called Zn function. So we're looking at number functions. Here we have Zn function. Okay, so this returns if it is not null, otherwise returns 0. So if you write Zn of expression or any number, so what it does is it will return the expression if it is not null, and return 0 if it is null. Okay, so if the value is null, then it will return 0. So basically this Zn function is used to replace nulls with 0. So non-null values will be replaced with the value which is there in the field. Okay, so Zn is nothing. Zn represents, it's a short form of zero number. Zn is short form of zero number. Okay, so it takes the input as an expression. Okay, so it takes the so syntax is Zn of expression. Zn of expression. So it takes the input as expression. So if the expression is null, it returns 0. If the expression is null, it returns 0. Else it will return the same expression value. Okay, so we'll see with an example. So say we have products A, B, C, and D, and um, the expressions are sum of sales, and we have values like 100, null, 200, and null. So when we use Zn of expression as our function, okay, so Zn is a function on expression. So we will have, will the result will the resultant set will have for non-null functions, for non-null values we will have same expression value 100. For null expression value we will have zeros. So 200, 200, null, 0. So basically Zn function is used to replace all the nulls to 0. Okay, so Zn is 0 number. Okay, right. So we have round here. So round function will round the number to the required number of places. Okay, so the syntax is round of number, comma, number of places, or n. Okay, so round the number which we have to round and number of places we have to round. Okay, round number, comma, n, or number of places. So this is the syntax. So first we will try to understand the logic behind the round function. So while rounding the decimals to n places, so as you can see, the result is 3.1 here. So the logic behind it is, so while rounding the decimals to n places, round will check the n plus 1 value. Okay, so it will check the n plus 1 value. So, and if n plus 1 value is greater than or equal to 5, then it will add 1 to the n value, else it will display n value. Okay, so how it functions is, so for example, if you take a round of 12.1124 comma 2, so as per the syntax, uh, round is a function name, 2.12.1124 is the number, 2 is the number of values, number of places that you want to round it to. Okay, if you take this input, so the resultant set would be 12.11. Okay, the result is 12.11. So what is the background logic which is happening here is, so while rounding the decimals to two places here, while rounding the decimals to two places, so n is 2 here. So if you take 2 as n, so n is 2 here. Okay, so n plus 1 is 3, n plus 1 is 3. So basically round will check the n plus 1 values. So n plus 1 is 3 here. Okay, so um, 3 means it will check the third value. So what is the third value from the decimal? 1, 2 and 3. So the third value here is 2. Okay, third value here is 2. So is 2 greater than or or less than 5? It will check whether the value, the n plus 1 value is greater than or or greater than less than 5 or greater than or equal to 5. Okay, if the value is less than 5, it will return n. So it will return n. So n is 2 here. Okay, n is 2, the second place. Okay, so that means the second number is 1 here. So so now, because n plus 1, which is a 3, third place is 2 and 2 is less than 5, it will return again 2. So which is second place, which is 1. So it will give 1 in this place, 1 in this place. Okay, so if you take another example with a round of 12.1154 comma 2, this will give you 12.12. So what happens is, um, while rounding the decimals to n places, so n is 2 here, n is 2 here. Okay, so round will check the n plus 1 places. So n plus 1 is 2 plus 1, 2 plus 1 is 3. So it will check 3 places. So the 3 places are 1, 2, 3. So the third place is 5 here. So it will check the third place, n plus 1 value place with 5. So 5 is equal to or greater than 5, right? So if it is equal to or greater than 5, it will return n plus 1, n plus 1 value. So which is which is n plus 1 value is what? 1 plus 1. So it will add this n and it will add 1 to this n. So it is 2 here. 1 plus 1 is 2. So it will return 12.12. So this is the logic behind this rounding function. Okay. So if you take round of 12.1154 comma 0, it will give you 0 decimal places, and it will give you the resultant set as 12. Right. So the result would be 12 here. So we'll drag this into the view and convert it into dimension. So the answer is 12 here. So what we have done here, we have done round off the number and the number of places. So number of places is 0. Then we will take the result would be 12 here with 0 decimals. So if you don't give comma 0 also, it will give you the same result, 12. Okay. Right. Also, so here observe that this 12.1154 is giving you 12. However, if you give 12.54, so what will be the result? Comma 0. If you give 12.54 comma 0, what will be the result? So the result is 13. So it will round off to the nearest number, which is 13 here. So similarly, we can ignore this 0, and if you even give this round off the number, you will get 13 as the output. Okay. Right. So there are few more functions in numbers. So we have uh, logarithmic functions in number functions here. So in Tableau we have two types of logarithmic functions, okay, which is ln and log. We have ln and log. So ln returns natural algorithmic value of the given number. So ln returns the natural algorithmic value of the given number. So if you take ln of 5, it will return the natural logarithmic value of 5, which is 1.60944. Similarly, we have log. Log gives you base algorithmic values. Here I'm taking log, and we have to define a base here. Okay. So for example, 256 and base of 2. 256 is the number and the base is 2. So we have to, this is the syntax, log of number comma base. So this will give you the output as 8. Okay. So log gives base algorithmic value. So where in the syntax you have to give log of number comma base value. Okay. So we also have exponential value. Okay. So exponential function takes the input as number and it raises the number to the power of e. Okay. So the syntax is exp of number equal to e to the power of that number. Okay. So exp of 2 will give you 7.2 something, 7.3938906. This is the e to the power of 2 value. Okay. So from Tableau 9 we have few more new functions added. So from Tableau 9 in number functions we have few new functions added called floor, ceiling, floor. Okay. So we'll see what a ceiling and floor is. So these are added from Tableau 9. So ceiling function returns nearest highest integer. Okay. So for example, if you write ceiling of 3.1415, it will give you 4. So ceiling function returns the nearest highest integer. It will returns the nearest highest integer. Whereas floor returns the nearest lowest or equal integer. Okay, it will the floor returns the nearest lowest or equal integer. For example, if you take 3.1415, it will give 3. If you take floor, if you take ceiling, it will the same number will give you 4. Okay, so we'll see the difference. Ceiling of 3.1 will give you. So what will be the output here? 3.1 output will be 4. And what will be the output if we change it to 3.99 using ceiling? Any guesses? So
What was
what?
the question, Kanti?
So in ceiling, if you take 3.99 as a number, so what will be the output? So ceiling function returns the nearest highest integer. Nearest highest integer. So what will be the output if you take 3.99?
No idea currently.
4.
4, okay.
Nearest highest
Of course, it
integer.
will round it off, you're saying, right?
Yeah. The nearest highest integer is 4 for 3.99.
Okay.
Okay, so we'll do the same using floor.
So for example, like if you take this, it would go to like 13 here.
Yeah, it will go 12.5, 12.54 will return 13.
Okay.
And if you use floor here, so what will be the output for 3.99 for floor? So floor function returns the nearest lowest or equal integer. So it will return an integer. So output will always be an integer. So what is the lowest integer of 3.99? 3.99 is 3. So the output
Okay,
would
so
be
I was
3.
on mute, sorry. Yeah, I said 3.
Okay. Yeah. Right. So even if you take 3.1, the output would be the same, 3.
Okay.
Okay. Right. Okay. So these are the few of the functions. We have to note that in real time we mostly use ABS function. In real time scenarios, we'll mostly use ABS function. Zn is the function which we'll use very frequently. We'll be using sine. We'll be using sine here. We'll also use square. We also use div for a division function. We'll use div.
You passed it.
Yeah,
That
div function, and also round, ceiling, and floor.
round ceiling and floor. Okay.
Yeah, yeah, round, ceiling, and floor. These are the functions that you frequently use it. Okay, so yeah, round, ceiling, and floor. Ceiling, ceiling, and floor. Right. So the next type of functions are string functions. Okay, we have seen number functions. We'll see string functions. So here we have ASCII. So if we take ASCII, it takes the input as string and it gives the ASCII number of the starting character of the input string. Okay, so for example, in authors the starting character is A. So the ASCII number for A is 65. Sorry, for small a is 97 and for capital A is 65. Okay, so you have to remember that ASCII numbers are different for uppercase letter and lowercase letters. So for each case, the ASCII numbers are different. Okay, and also space is a character in Tableau. So we have to make a note of it also. Space is a character in Tableau. Okay, so ASCII, what it does, it takes the input as string and gives the ASCII number of the starting character of the input string. Starting character here it is A. Okay, so if you give ASCII of any letter starting with small a, it will return 97. If you do the same with capital A, it will give 65. Okay, if you give apple, it will give 97 again. Okay, so we'll see that. So ASCII of capital A is 65. Okay, right. So we'll use the same to edit. So we also have in string functions char. Okay, char takes the input as ASCII number and gives the equivalent character. Okay, so for example, if you give char of 65, it will return capital A, and if you give char of 97, it will give small a. It will give small a. Okay, so similarly, if you change this to 65, it will give you capital A. Okay, so in strings we have also Boolean function. So there are different types of Boolean functions in string types. So we'll take string and uh, what are Boolean functions in the first place? So functions which have outputs either as true or false are known as Boolean functions. Okay, so the output should be either true or false. So if the output is either true or false, then that type of a function is known as a Boolean function. So in in Tableau we have three different types of Boolean functions. So which is starts with, ends with, ends with, and contains. So starts with, ends with, and contains are three Boolean functions. Okay. So we'll first look into starts with. Right, starts with checks whether the search string is exactly matching with the starting part of the input string or not. Okay, starts with will check whether the search string. So the syntax is starts with of the search string. Sorry, start with of the string, comma search string. So it will return either true or false. Okay, so syntax is starts with bracket of in brackets the string that we want to search, and the search string is CA here in calculation. So what starts with does is starts with checks whether the search string is CA here is exactly matching with the starting part of the input string, is exactly matching with the starting part of the search string, input string. So calculation is the input string, CA is the search string. So CA, the search string would be checked with the input string. Okay, so if it is matching, then it will give true, or else it will give false. Okay, so for example, you starts with um, say Tableau. This is the input string, and the search string is comma, search string is TA. So will this give you true or false? Because the starting string is TA in Tableau, the result would be true. So if you give a small other case, different case, like small t and small a, it will not accept. So it will return false. So it is case sensitive. Okay, it is false, right? So similarly, we'll use ends with. So ends with checks whether the string is matching with the ending part of the input string or not. So if it is matches, it returns true, else it returns false. So here, if the ending part is AU, right? Capital AU. So if you write this, it will give you true. So we have to change it to ends with. Okay, this will give you result as true. So if you change the string uh, case to small, or if you write say AB here, so it will return false. Okay. So similarly, we have contains. Okay. So what is this? So contains will check whether the search string is existing in the input string or not. If it is existing, it returns true, else it will return false. So the syntax is contains string and substring, or search string. You can also call the substring as search string. So AB is there in Tableau, so it will return true. Okay. So if you write something else, some other string which is not there, like BE, it will return false. Okay. So these are the different Boolean functions that are there in Tableau. What are the Boolean functions in Tableau? Starts with, ends with, and contains. We also have substring functions. Within string functions, we have substring functions. What are substring functions? Left, right, and mid. These three functions are called substring functions. Okay, left, right, and mid. Left, right, and mid. So these three functions are called substring functions. So what these substring functions do is, so substring functions extract the required subpart of the string from the input string. So they extract the required subpart. They extract the required subpart of the string function. Input function is the input string from the so they from the given input string. So there are three substring functions in Tableau, which is left, right, and mid. So we'll see left first. So left displays the number of characters from the left part of the input string. So it will display the number of characters from the left part of the input string. So the syntax is, left of uh, string comma number of characters, left of string comma number of characters. So left of Tableau comma 3. If you give 3 here, so this will give you from left 3 characters, which is TAB. The answer is TAB. Okay. Similarly, the right will display the number of characters from right part of the input string. So if you take right here and 5, so it will give BLEAU. Okay. Similarly, mid displays the substring from the input string based on the starting position and the optional number of characters. Okay, so we have to define a starting position and also uh, number of characters. So number of characters is optional. If you give the number of characters from the starting position, it will take those number of characters. If you omit this number of characters, it will display the string till the end from the starting point position. So we'll see the syntax. It is mid. So syntax is string mid of string comma start position comma number of characters. Okay, mid of string comma start position comma number of characters. Okay, or length, number of characters or length. So here we can take Tableau 3 comma 3. So this will give you from third position it is B, and from 3 BLE. So the result is BLE. Okay. So if you don't give the number of characters, it will take till the end. So starting from the third character, so it will display till the end. So it will display BLEAU if you don't give the number of characters. BLEAU. Okay. So in the syntax, if you give 0 or if you don't give any starting position, so it will take the complete text. TA So we have to first convert that into right here, mid of Tableau comma 0. So we have to define starting position to get the complete string. Okay. If you give 1, you will get the complete position. So, right, if you give 0, it will not give any result. Okay. Right. So we'll perform a task now to understand this better. So in this task, so we'll take a quick break of a couple of minutes and we'll come back and perform the task. Okay. Yeah. See you in 2 minutes. Right. So we'll perform the task now. So we'll display item wise. We'll display item wise order quantity. Item wise order quantity of those items whose name contains. So of those items. So in items, the item name should have Canon, Xerox, IBM, and AT&T. So these are the texts that we should first look into before displaying order quantity. So we have to display for only those items which are containing few text items. So first we'll create a parameter with the name item search. So we'll create a parameter. So we'll name this as item search and enter the values. It is string here. List. The values would be Canon, Xerox, IBM, and AT&T. Click on OK. And we'll display the parameter. Now we'll create a calculated field with the name item search. In this we'll use contains. We'll select string, which is item, and the substring is item search, which is a parameter that we have created. So item search is nothing but a parameter. You can write a comment here. Okay. And calculation is valid. We'll click OK. So we'll drag item into rows. So these are the all items that are there in the data source, and then order quantity into columns, and item search field into color. So this is a Boolean returning true or false. So we'll keep this into color. Okay. We'll select true and we'll keep those only. So these are all the items which is having uh, the text canon. So we'll actually it might be case sensitive. So we'll change this to capital X, capital IBM, and AT&T. Yeah. So here we have Xerox, IBM, and AT&T. Okay. So based on the selection, we will have only those items which is having the search item or a substring called Canon, Xerox, IBM, and AT&T. So out of all the items, we are displaying only a specified item based on a condition defined in the parameter here, which is a substring, and in the calculated field we have used a function called contains. So in contains we are using item as a string, and the parameter created item search as a substring. Okay, so using contains function you can perform such type of an analysis, right? Okay, so we can also display all the customers whose name is starting with A, B, or C. So we can also perform such type of an analysis. So we'll drag customer names into rows. So this is having list of all the customers from A to Z. So however, we only want customer names whose name is starting with A, B, or C. So we'll drag sales into columns and customers and their sales. We'll drag customer name into filter. Here we'll go to condition by formula, and we'll write a formula left. So left of customer name, comma 1. So this is a number of characters. So left of string is customer name, and number of characters is 1, which is A. So equal to A, or So we want A, B or C. So we'll use three conditions here. Okay, let's click on apply. And this will show only those customers who is having names starting with letter A, B or C, and rest of all will be excluded. So here we have used a function called left. Okay, so using such scenarios you can analyze the data like this. So we have a next set of functions in string called trimming functions. So uh, we have uh, three types of trimming functions here. So which is L trim, R trim and trim. So we have L trim, R trim and trim. So these are the three trimming functions available in Tableau. So L trim eliminates space from left part of the string. So if you use L trim and in the string you give within brackets space Tableau space. So this will delete all the spaces on the left side. So and this and on the right side the spaces remain. So only the left space would be removed using L trim. So the result will have left space removed. So see, as you can see, there is a space after you. So on the right side there is a space here. So if you use the right trim, R trim, so it eliminates space from right part of the string. So here it has been deleted. So right part of the string has been deleted. So rtrim will delete the right space. So right space will be deleted here. So we also have trim here. So trim will delete, it will eliminate the space from both parts of the string. So both left and right. This will delete both left and right parts of the string. Okay. So in the strings we have length function, len function. So len gives the length of the input string. Okay, the syntax is len of the input string. So the length of the input string calculation is 11 characters. So it will give the output as 11. So we have to note here that len of first name is considered as measure. By default measure converts that field into dimension. So if you it will be actually, if you calculate that, it will be converted into measure. So we have to convert that into dimension and then drag it into the view. So similarly in the same string functions you have replace. So replace function will check whether the search string is available in the input string or not. Okay, so what this function does is it will check whether the search string is available in the input string or not. So we have a search string and the input string. So this is a search string, this is the input string. So input string is the actual string that we are checking it with, uh, checking against with, and uh, the search string is the string which you are checking it with. Okay, so if it is available, it will be replaced with the replacement string. So we have replacement string also. So if it is available, here in calculation, if ION is available, it should be replaced with ED. So the resultant is calculation will be converted into calculated. Okay, so if the search string is available in the input string, so it will be replaced with the replacement string. So if it is not available, it will display the input string as it is. Okay, if it is available, it will be replaced with the replacement string, or else the input string will be displayed as it is, like this. Okay, so the syntax is replace of input string comma search string comma replacement string. Okay, right. So we have to note here, while working with replace, that replace will replace all the strings, search strings, with the replacement string, even though if the search string is appearing for multiple times. So for example, if ION is appearing for multiple times in the input string, so ED will be replaced wherever, how many ever times the ION is appearing in the string. So if multiple times ION is appearing in the input string, so that multiple replacements will happen in the output. Okay, we have to uh, make a note of, or take care while using replace function, if that is the scenario. Okay, okay, this is about replacement string. We also have case conversion functions. So what are the case conversion functions in string functions in Tableau? The case conversion functions are upper, lower, upper, lower. Okay, so these are the case conversion functions. So upper, the syntax of upper is upper of string, upper of string. So that will convert to uppercase. So if you use small letter cases, it will convert to caps. Similarly, lower will convert to lower of string, will convert from a caps letter to a small letter case, small case. So 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 if you want to combine any two strings, so this is about case conversion. So if you want to combine any two strings, we do not have any function in Tableau like concatenation. So we have to use plus operator only, plus operator only in Tableau. So we have to, in calculated field, first we have to select the first string and use plus, and then second string. So using plus operator, we can combine two or more strings. Right. So we have space. We have space also here. So space will take the input as number, and it allocates the required number of spaces. Okay. So space will actually take the input as number. So the syntax is space of number. Okay. So space will take the input as number, and it allocates the required number of spaces. So we'll perform a task to use space function. So we'll combine three strings. One is Tableau, one is say um, training, and the other one is some uh, training time. Okay, so we'll create a calculated field first. And name this as string concat. Here we have Tableau as the first string. We have to enclose in brackets. This is the first string plus space of 2. We want two spaces after Tableau, plus we are concatenating it with training, so we have to enclose in quotes, plus space of 2. So we want one space, so we'll take space of 1, plus we are concatenating with some time. Okay, 8:30 p.m. Okay, so we are concatenating the three strings: Tableau, training, and time, and using space functions as well. So we'll see how the output looks. So the output looks like this: Tableau, training. Tableau and training has two spaces between, and training and the time has one space in between. So we have used concatenation using plus, and also uh, and also you also use spaces. Okay, so this is how you can create uh, concatenated strings. So we have minimum and also maximum functions in Tableau. So minimum and max. So the syntax is minimum of string and maximum of string. Okay, so minimum and maximum functions takes the input as string, and it returns the string having minimum ASCII number and or maximum ASCII number. Okay, so it considers minimum or maximum ASCII numbers, and it will returns minimum or maximum. Okay, so we have to note here that if we apply minimum or maximum functions on a string data, Tableau will create the output field under measures. So we have to convert that into dimension. So this is about minimum and maximum. Right. So we'll see how we can do that. So we'll create two calculated fields. So first one is min. Min of customer name. right? Similarly, we'll create max. Max of customer name. So we'll drag minimum and maximum into rows. So we'll get the minimum and maximum of the string based on the ASCII numbers, minimum ASCII number and the maximum ASCII number. Okay. So similarly, we can use minimum max for uh, measures as well. So here you can write minimum of sales and maximum of sales. So this will give you minimum and maximum numbers within sales measure. Okay, right. So we also have a function called find. Okay, so find function finds the search string in the input string. If it finds, it returns the string position of the input string, else it returns 0. So what find does is, so find function finds a search string. So in this example, we have calculation, right? So this this the search string is ALCU. Okay, so and the input string is calculation. So find function finds the search string, which is ALCU, on the input string, which is calculation. If it finds the, if it finds this into in the search string in the input string, it returns the string position. So the string position is 2. So 1 2. So the string position is 2. It returns the string position if it finds. If it doesn't find, it will return 0. It will return 0. So we'll try with an example. So find comma A. So the position is TA. So second position. Okay. So we will write another text which is not in the not in the not in the input string. So this will return 0. This will return 0. So I've used BE, which is not there in TABL so which will return 0. Okay, right. So we have a few more new functions in Tableau from Tableau 9.0. So from Tableau 9.0, we have few more new functions. So we have find nth, we have split, we have split, and we have regular expressions. So we have regular expressions. So we'll see them one by one. So from Tableau 9, we have these three new functions. So we'll first see find nth. Okay, find nth. So here we have find nth. So find nth will return the nth occurrence of search string in the input string. Okay, find nth will return the nth occurrence of search string in the input string. So for example, um, so first we'll see the syntax. So the syntax is find nth of string, the input string, comma, the search string, comma, the nth occurrence, the nth occurrence. So if you take find nth calculation, comma, a, comma, 2. So the resultant would be, the result is 7. 1 2 3 4 5 6 7. Okay, so the next result is 7. Okay, so find nth will return the nth occurrence of search string in the input string. Okay, so the syntax is find nth string, search string, and nth occurrence. Okay, so this will give you 7. So the nth occurrence, because this is the 7th position which is occurring again. So similarly, if you take find nth in the string Tableau and give text A and occurrence as 2, so 1 2 3 4 5 6, the output would be 6, because the next occurrence is 6, so the answer is 6. Okay, right. So if the nth occurrence is not available, so it will Tableau will return 0. So find nth function in Tableau will return 0 if nth occurrence is not available. Okay, so now we'll see split. So what will happen if we do, if you give find here rather than find nth? So what will be the output? So if you give find nth, you'll get 6 as output, because 6 place it is having another alphabet. However, if you take find, the output would be 2, because it will take only the first occurring letter. So the output would be 2. So now we'll look at split. Okay. Split is used to split the input string based on the split character and split part. Okay, we have split character and split part. Okay, so based on the split character and the split part, we can split the input string. Okay, so the syntax is split of the split character, which is ABC A hyphen C B hyphen C hyphen D, comma, the split part is hyphen. Okay, and sorry, we have string, and the split part, split character and the split character and the split part. So we have this syntax as split of the string. This is the string, and the split character. Split character is hyphen here, and also split part. Split part is 2. Okay. So this will give you B. So the split part is 2, so you'll get B here. So if you give the split part as 1, you'll get A here. Okay, and the split character is hyphen, so it will split into different parts. So if you give 3, you'll get C. If you give 4 as a split part, you'll get 4. You'll get D here. Okay, right. So we'll also do that here using a calculated field. Split of so we'll take underscore here, A underscore B underscore C. So this is the string, and the split character is underscore, and split part is 1. So what will be the output here? What will be the output here? Guys, what will be the output? So we are using split here. So A underscore B underscore C is the string here, and underscore is the split character. The part is 1. Split part is 1. So what will be the output?
It will be the same, but the 1 would change to 2.
No, output. What will be the output for this? So this is for split. This is a calculated field for split. So as per the syntax, so A underscore B underscore C is the string, and
Okay.
the underscore is the uh, split character, and 1 is the split part. So A is one part, B is one part, and C is one part, and underscore is the split character. So if you use 1, so what character will be the output? So we are basically
A, right?
yeah, exactly, A. So we are splitting the character A underscore B underscore C using a character called underscore, and the split part is 1. So there are 3 parts, 1, 2, 3. So if you're using 1 as a split part, the output would be A. Right. So if you change it to 2, you will get B. If you change a split part to 3, you will get 3. Okay. Right. So we'll perform one more task on customer name using split. So we'll first create a calculated field. I will name this as first name. Here we'll use split. Customer name is a string, and space is the split character. Space is the split character, and we want the first name. That's why we'll use first part. Okay, the split part is 1, So this will return what?
The
What will,
customer name, right? Or the customer.
so customer name has two parts in it, the first name and the second name.
Okay.
So we are splitting the customer name with the this is the string, customer name is the string, and space is the split character.
Mm-hmm.
So customer has first name and second name divided by a space character. So we are using split character as a space and the split part as one. So if you are using one, so there are two parts, first name and second name. So if you are using one, you will get first name or a second name.
The first name.
First name. If you use two, you will get the second name. So if your requirement is to get only first name of customer name, you will use split function. Okay, right. So
Okay.
we'll click OK. So similarly, you can use uh, 2, 3. So if the output if the data is having middle name also, you can use 2 for middle name and 3 for last name. Okay. So first name. Yeah, we'll drag this first name. First we'll use customer name, and then first name. Okay, what happened to this calculated field? I'll create this again. And I'll drag next to customer name. Okay. So you're able to see the first name of the customer like this. Okay. So if you don't want of the full name, you can remove that customer name as well and only keep the first name. Okay. Right. So similarly, we can use a few more examples also. So I'll give them as assignments to you, so you can perform them and then get back to me. So now we have date functions. Okay. So we have date functions also in the string functions in Tableau. Okay. So within date functions, we have subdate functions. So subdate functions extract the required date part or subdate from the input dates. Okay. So subdate functions will actually extract the required date part or a subdate from the input dates. So there are 5 different subdate functions in Tableau. One is year, the other one is month, other one is day, okay, and date part or date name, okay, and we have uh, okay, we have date part, date name, day, month, and year. So these are the different subdate functions. Okay, so year will extract year value in the form of integers. So it extracts in the form of integer 2013, 2014. So these are the different types of integers. So year function will extract year value in the form of an integer. So the syntax is year of order date. Okay, this will give you the years in the form of integers. Okay, so similarly we have month. So it extracts the month values in the form of integers. So you can give month here. We'll give month here. So this will give you all the month numbers. So okay, in the form of integers. So month will also give you month numbers in the form of integers from first month till 12th month. Okay, so we also have day. We also have day. So here we have day. So we'll convert this into day. So this extracts the day values in the form of integers. So we'll use day of order date. Okay, day of order date. So give you this will give you the days. Okay, so there are 31 days in a month. So you'll have 31 days in the form of an integer. So also you can use the date function as well. So this will give you the dates like this, all the dates in the year. Okay, all the dates in the year using date function, date of the input date. We also have date part and date name. So these extracts the required subdate or subtime values from the input date or date plus time values. So you can either use input date or date plus time values also. Okay, so the date part gives output as integers, whereas date name gives output as strings. So date part, so the syntax is date part of date part comma date or day plus time. Okay, so this will give you the output as integer. So if you use date part, so if you use date name, so the syntax is date part comma date or date plus time. So this will give the output as string. This will give the output as string. So so we have to define a date part here. So first we'll look date part here. So as per the syntax, we have to give a date part. So date part could be quarter, okay, comma date. So as per the syntax, we have to give date. So we'll choose order date for that. So quarter is the date part. Quarter quarter is the date part. So we have to show them in brackets. Show it in bracket. Okay. Quarter is the date part. So date part function. Quarter is the date part, and the date is order date. Okay. So this is a valid calculation. So if you use capital Q, so it is not a valid calculation. So for quarter, so you should use small q only for for getting a valid calculation. So instead we'll use small q. Small q is the valid date part for quarter. So we have to note here that for any date function, date part must be specified in the lower case. So you can specify quarter, month, okay, year, year, and also day. So these are the different date parts. So however, we have to specify them in lowercase only. If you give it in uppercase, it will not accept. Okay. Right. So click OK, and this will convert that into different dates because we have created date part. Okay. Right. These are the different functions. So we'll continue with the rest of all the date functions in tomorrow's class. So okay. So these are the different functions we can use in calculated fields, and we'll discuss few more in next class. So next class would be next week on Monday. Okay, see you on Monday then. Okay,
Yeah,
have a
okay,
great week.
Karthi, bye.
Yeah, bye bye.